there's two ways to measure the humidity or the amount of moisture in the air. There's two ways I can measure the amount of water in this container. One is to say how much actual water is in there, 1 cup or 8 fluid ounces. That doesn't matter the size of the container. If I pour this back and forth, it's 1 cup or 8 ounces of water. That's one way to measure it. The other is how much is in there compared to the size of the container. Well, this is a 1 cup of water in a 4 cup container, so this is 25%. But if I move it to a different container, it goes to 50%. So one is how much is there actually. The other is how much is there as a percentage of how much it can hold in that container, or for our purposes, that temperature. Okay, then you should do it.
Wait, Darren, can you repeat that? Sorry.
Yes. I got your text message, so yes, go. I will let staff know what's happening. Hold on just a moment. That's someone who has to get out of their building right now. Okay, sorry about that. Yeah, so what I was saying is there's two ways I can measure the water that's in here. One is the actual amount, 1 cup, 8 ounces. The other is the percentage compared to the container it's currently in. 1 cup of water in a 2 cup container would be 50%. 1 cup of water in a 4 cup container would be 25%. So it's only, if I don't know the size of the container, then I don't know what the percentage is. I have to know how much it can hold and how much is in there, because it's relative to the size of the container or relative humidity. So we're going with that. So let me know if that helps or not. If that makes, and we're not done with that one yet either. We're going to kind of do several examples on this moving forward. So as we talked about the humidity ratio or the GPP, that's the first way to measure it, is the actual amount of water, is the weight of water in the air, is how many grains per pound of water in the air. So I'm going to show you more on this in a moment. And again, just like the example I gave you, why do I care? Well, if inside this room where I'm at right here, let's say this is inside, and let's say it is, well, it's 75 degrees inside, and let's say that outside it is 30 degrees, and I open the window, which way is the heat or energy going to flow?
Out.
Yeah, it's leaving the building. Absolutely. High is going to go to low. Now, if outside, it's 80 degrees and I open the window, a little bit of energy is going to come in. High is always going to go to low. So that's comfortable. That's temperature. We know how that works. We open the door in the wintertime and it starts to get cold inside. But let's say instead of temperature, let's say, just so you know, this button right here is supposed to erase. And sometimes for some reason it doesn't erase. It scribbles and laughs at me. I don't know why it does that, but okay. So let's say that inside I have 110 grains of moisture per pound of dry air, and outside it is 80. Wow, this one's really giving me a bad time today. Let's say that outside it's 80 grains per pound, and I open the window. Which way is the moisture going to flow?
Outside?
Yep, it's going to go out. But if outside it's 130 and inside it's 70, and I open the windows, then it's going to come in. This is why in August, if you're trying to dry a house in Florida, you don't want to open the windows because there's so much moisture in the air outside. It's hot, that's good, but it's wet, and that's not good. But if you're in Phoenix and it's 137 degrees on a cool spring day, and you open it, now that's probably going to be good because that hot dryer, we'll talk about that. Okay. But that's why I care about grains. It tells me which way my moisture is going to move. High grains is going to go to low grains. High amounts of moisture will go to low, just like high temperature goes to a low temperature. And so again, just to recap, our humidity ratio is based on 1 pound of air, dry air. Now, again, I want to point out, this air is not dry. It has moisture in it. We're just counting it separately than everything else. How much moisture per 1 pound of anything else that's not moisture in there, or 14 cubic feet of air? 7,000 grains is the same as 1 pound. 14 cubic feet is about 1 pound of air. So, I talked about the fact that it was based on grains of barley, but it's not the number of grains, it's how much that they weigh. So my humidity ratio is not saying I have 1, 2, 3. No, it's saying if I gather those together and put them on a scale, how many grains would they weigh? I can't use ounces or pounds. That's too big of a number, too small of a number. I'm going to use grains for that. Too small of a number is what I should have said. All right. And so again, if I look at this, if inside it's 80 grains and outside it's 50 grains, I open the window, moisture is going to leave. If it's the opposite, moisture is going to come in. If you look at this dehumidifier right here, it has the thermal hygrometer gathering information. It says the air coming from the room into the dehumidifier is 93 degrees, 51% relative humidity. We're going to go through why this does this in a few minutes. That would be 126 grains of moisture in every pound of air right here coming into the dehumidifier. And the air coming out is at 63 grains. There's a difference or a delta of 62 grains. It's 62 grains less going in there. Let's take a look at this just for the heck of it real quick, because again, I keep trying stuff. We'll see how this works out here, but just to give a visual, I like visuals. So here it is. Let's use this right here. So I'm going to use this little dish right here, this little plastic dish, and I'm going to put it on here. Turn this on. And actually, let's get another little plastic dish and we will do. All right. So what I'm going to do here, I hope, we're going to focus on the 126 grains and the 63 grains. That's what we're going to do here for just a moment. So I'm going to turn the other camera on, I hope. And I'm going to say this is going to represent the air that's going into the dehumidifier. So I'm going to turn this on. Let me tear that out. Okay, so let's take it from grains. Let's go to grains on here. Okay, so I get 0 grains, and there's 126 grains of moisture going into that dehumidifier. So let's pour a little water in here and see how close we get. Woo! Nice job. Grab my little dropper, throw a little bit more in there. Ooh, okay, so that right there is 126 grains of water. And then coming out of the dehumidifier, there are 63 grains. Now it's just mocking me. All right. You get the idea. The problem is I have just enough OCD. I want to get it exactly right on, but it might not happen this time. We might just have to go with it. So generally speaking, you see that that's about what we're looking for. 60, 62, 63 grains. So what we are literally saying here is, if I were to take this many grains of water, this is 126 grains of water. That's how much it weighs, which is a little more than 1/4 of an ounce of water, which means the air going into the dehumidifier has 126 grains. Every 1 pound of air has this much vapor floating through it. If I were to evaporate this up into the air, that's how much would be in this air. That's what's going into the dehumidifier. Because it's a dehumidifier, it's pulling moisture out. So the air coming out of there it has 63 grains of water, which is good. The air coming out should be drier. So that's the visualization of saying this is the actual, when I say that there are 126 grains of water per pound of dry air, that's what we're saying is this section of air has this much water vapor floating through it. Okay, that's what the grains are, and that's what it represents. So if this air, again, I could do the same thing. I could get a little dish and I could put 80 grains of water in it and another one 50 grains and show the difference and how one is going to, literally I could pour it in here to equal it out. But if it's vapor, it's just going to move back and forth. That's my grains of water in one section of air. Any questions on that? Does that make sense? It's the weight, it's the actual weight of the water vapor floating through a section of air because that represents it. So that's the one way. The second way is relative humidity, or based on how much you can hold. So let me ask a question here. We'll work with you. If you're still right there, we'll work with you on it. So if I came to you guys and said, hey, I am willing to sell you 50% of my company and I want $1 million. Is there any other information that you would want before you write me a check?
Revenue,
Well, I want to
gross
know how much
profit.
the company's worth.
Wow. Okay. So you want to know the revenue, how much money's coming in. You want to know what the company's worth. What's the value? Okay. Those are good questions. I would definitely want to know that. What else would you want to know? What are the questions everybody have?
Do
That's
you
it.
have a good reputation? Have
That's a
you been
great question.
going 50% on jobs that needed 100?
Yeah. So what's your reputation? How are you doing on the jobs? Do you have any lawsuits going on? Good questions. Okay.
How much you bringing in?
Okay. Yeah. What's your revenue? What kind of money's coming in? Absolutely. What else?
Expenses.
What's it costing you, right? If you're bringing in this much money and spending more, you're not making money. So yeah, how much is coming in? How much is going out? Or how much is left over? Great questions. Okay. Anything else?
Labor cost.
Yeah. What's it cost you to run those jobs? You'd be profitable on those. So great questions. You might want to know about inventory. How much stuff do you own? How much do you know? What's your liabilities? You know, how much you own? How much you owe? All that kind of stuff. Great questions, right? Really good questions. But all these questions, I mean, I'm offering you 50%. That's a pretty good percentage. Right? I can take all of the questions you just asked, which are excellent, and put them into one question. 50% of what? Because that's really what you're asking. If someone gives you a percentage and you don't know what it's a percentage of, it's worthless information, right? And that's the point I'm trying to make is, so I could say,